Lesson 48, page 342. It's Wednesday, November 7th. Lesson 49 tomorrow, lesson 50 on Friday. There's no school on Monday, so our test will be on Tuesday. And there won't be any homework on Friday except for studying, of course, for your tests. So looking at lesson 48, relatively short lesson today. Plenty of time to do your homework in class, hopefully, so you don't have to take it home with you. And we'll look at our first, or not our first example, but actually we're going to go to the new concept, which once again, it's not really new. You guys have had this or seen this before, which is a good thing. That makes my teaching job easier for, it's easier for me, since I don't have to teach you something new. It's an old concept. So we're going to start out, hopefully, with a circle somewhere around here. Really? Let's see if it's going to work where I want it, the way I want it to. Wow. No, it is not. Okay, forget that. Can't do what I wanted to do. Alright, so here we go. Need some color. What's going on here? There we are. Got my circle. Draw a line halfway through the circle. Not exactly 50%, but not bad. A couple ways we can write this. We can say, now I'm not even sure I want to do this without messing it up, but we're going to try. There we go. We can say now that 1/2 of this is shaded. 1/2 is shaded. And you would agree with that. We can say that 0.5 of the circle is shaded. And we can also say that 50% is shaded. All saying the same thing. Would you agree? All right. So, do you have a question? Oh, no, no questions? Okay. All right. So these are just 3 different ways of saying basically the same thing. The idea is, how do we go from one to the other? If we know something is 50%, how do we put that into a fraction? Can we put it into a fraction? How do we put a fraction into a decimal? Can we? Can a decimal go into a fraction? Can a decimal become a percentage? These are some of the things that we're going to be looking at today as we look at the idea of fraction, decimal, percent equivalence. So I'm going to delete this and go into our first example. It wants us to write 7/10 as a percent. Now listen, the rule of thumb here is anytime, and this has to do with the identity property of multiplication, but anytime you want to take this fraction and get it to a percent, if you multiply it by 100%, you'll get the answer that you're looking for. So when you take, remember 100% is like saying 100 over 1, right? So when you do this, you wind up with 700% over 10. And whenever we're getting or dividing by 10, it's or 100 or any number, any one that has zeros after it, you can do the division if you want to, or you can just know the shortcut, which is if you have a 0 here that you want to get rid of, you can get rid of one of the zeros up in the numerator, and then that leaves you with your answer, which is 70%. Okay, so you go from a fraction to a percentage sign by multiplying the fraction by 100%. Okay, everybody understand that? Okay, Tanisha? Then it would be different, of course. If this were, let's say it were 40, right? Then it would be 40. You would have 700 over 40, and it changes things a little bit. You can still get rid of the 0, but now you're dividing 70 into 40 to get a percentage, and you're not going to get it's not going to be the same scenario. But it's not going to be here. But first of all, it's not going to be over 40, because when you're talking about a fraction, it's always, at least for these types of problems, because we're talking about equivalencies between fractions, decimals, and percents. It's always going to be over 10, or over 100 or something like that, because we're going back and forth between decimals to fractions to percentages, so they have to be based on 10. Julia? Yeah, you can do that. You could do that. But and that's something that may happen a little further on down the road. So for right now, I really wouldn't worry about that so much. I just focus on this idea for now. They're keeping it easy, keeping it simple, because it is based on 10. And let's just make sure that we can do it this way. And then if they change it on us midstream, then we'll deal with that when the time comes. Our next example, it wants us to write 2/3. It wants us to write 2/3 as a percent. It wants us to write 2/3 as a percent. So now this actually jumps into what you just said, Tanisha, actually, in a sense, because we no longer have it over 10. So it wants us to write it as a percent. So we would take our 2/3 and we're going to times it by 100%. When we do that, we wind up with 200% over 3, because this is like 100% over 1. And so now we have 200% divided by 3. When you divide that, you get 66 with the remainder of 2 over the 3 becomes the denominator. And that's a percent. 66 and 2/3. Everybody see that? Okay with that? All right. Tanisha, did you get that? All right. Let me delete that. And then we'll go to example 3. Example 3, get a different color. Not really crazy about the colors we're using here. Okay, that's showing up all right. It wants us to write 0.8 as a percent. So once again, we're taking 0.8 and we're timesing it by 100%. And when we do that, we're multiplying. We're multiplying. So when we're multiplying, are we making the original number bigger or smaller? We're making it bigger. So which way does the decimal point go? It goes to the right. Yeah. Yeah, the decimal goes to the right. All right. Mm-mm. Remember, we're multiplying, so this is the original number, the 0.8. We're multiplying by 100%. So if we're multiplying, whenever we multiply, things get bigger. When we divide, things get smaller. The only way this number 0.8 is going to get bigger is if we go to the right. How many places do we go to the right? 2, because we have 2 zeros. 1, 2. So we go 2 places to the right. We go 1, and we go 2. We put a 0 right there. And over here it would actually look like 80%. Okay, because we're going 2 places over. We're going 1, we're going 2. So our number is 80, and it becomes a percent sign. So it's 80%. So 0.8 times 100% equals 80%. Could I have done it this way? Could I have taken 100 times 0.8 and then multiplied and got, oh yeah, right, got 0.008, and then went 1 place over because I have 1 decimal place? I could have done that, right? I could have done that. The other way's easier. Yes, Tanisha? What's that? 0.08? So you're saying if I had 0.08 times 100%? Okay, well, it would be 100 times 0.08. So the long version would be 008 and 0000800. I have two places, 1, 2, becomes 8 point, so it becomes 8.0 or 8%. It is 8%. 8.0 is 8%. Okay. Are we okay? This is something that might confuse you. I hope it doesn't. But since we're talking about it, let me just make sure that you understand something here. I'm going to give myself a little bit of room. Oh no, I hope it does. I hope it confuses you. I really won't be happy unless you're confused. Remember, Chelsea, so 0.01 equals, what percent is that? It's 1%, right? So 0.02 equals 2%. 0.03 equals 3%. 0.04 equals 4%. Yeah, 0.05. It takes a little long here, but I'm trying to make a point. 0.06 equals 6%. 0.07 equals 7%. 0.08 equals 8%. 0.09 equals 9%. And then 0.10 equals 10%. But this is why the 8's over here. It's 8%. You would think, well, if it's 8, why wouldn't it be here? Why wouldn't it be over here if it was 8%? Because the 1 over here, the 1 here makes it 1%. The 1 in this column makes it, remember, it's the tenths. So it's 10%. Remember, that's the tenths column. So a lot of explanation to make one small little point. Huh? If it was over 10%? If it was over 10? Well, here's what we have. If we have 8 over 10, we have to multiply that by 100% to get a percentage, right? And remember what do we get? Remember we have 800% over 10. We get rid of a 0, so it becomes 80. So the percent is 80%. Okay? All right. Everybody okay with that? No, hang on. If I have what? 0 point what? And I want to know what percentage that is? Well, you multiply it by 100 to do it. I just keep on changing. To do it the long form, just to keep it simple, let's just do it the long form, the way we're supposed to, times 0.111. This is going to be 0, 0, 1, 0, 0, 1, 0, 0, 1. It's going to be 1, 1, 1, 0, 0. And how many decimal places do I go over? 3. 1, 2, 3. Because when I'm and listen, the shorthand version of that, guys, is remember we're multiplying this number. This is our original number. We're multiplying it, so it's going to get bigger, right? It's going to go up. And how many places? 2 zeros. So we go 2 places. 1, 2. You never do it by. I mean, 1,000% is not. Everything is based on 100%. 100%. Remember the whole. The whole is 100. The whole is 100%. You can't have 1,000%. The whole. It's said to be complete or a whole at 100%. Are we okay with all that? All right. So then we have this example that I'm going to try to reproduce for you here. Let me do this. Let me get I don't like that. Don't like that either. Hmm. Don't like any of this. No. Put that down. Bad girl. All right, fraction, decimal, percent. Absolutely. All right, so we have this. We have 1/3 in here. We have 1.5 in here. We have 60% in here. We have 2 over 1 in there. All right, and we want to fill these out. So if our fraction is 1/3, what do you suppose the decimal for 1/3 would be? Okay, okay, all right. But what would the decimal be? 0. Point what? 0.33? Well, okay. So, hey guys, just because you know what, these are gonna be on the test from here on out. Because I remember last year, like every time we had a test, there was one of these. It seemed like there was one of these on there. The kids had to know. So, if you have this fraction, let's make sure we know this. If you have this fraction, 1/3, and you have to get the decimal, what do I have to do? How do I do this? I divide what into what? I divide 3 into 1. So I take my 3. Listen, make sure you watch me do this because some of you will not do it right. 3 divided by 1, right? 3 does not go into 1, does it? So I got to put a 0 there. Now, when I have 1 here, it's like saying 1.0, isn't it? So I can do this, I'm okay. So remember, when I'm dividing, my decimal comes right up. It doesn't move. It stays right where it was at. 3 goes into 1, 0 times. 3 goes into 10, 3 times. 3 times 3 is 9. Leaves me 1. I have to add a 0 and bring it down. Gives me a 0. Gives me a 3. 3 times 3 is 9. Gives me a 1. I have to bring a 0 down. Gives me a 0. Gives me 3. I already see that it's repeating, right? It's going to be repeating forever. So my answer here for the decimal is going to be what? 0.3 repeat end with that repeating bar over it. You got that? All right. Now for a percentage, I know that to find the decimal, once I have the fraction, I know that I have to divide the 3 into the 1 and I get my decimal. When I want to find a percentage, what can I do? Julia? Yeah, I mean, I take my fraction of 1/3, right, and I can multiply that by 100%, which is 100 over 1, and that gives me 100% over 3. And when I divide that out, I wind up with what? I'm writing this off the screen, but it's 33 and 1/3. Okay, it's 33 and 1/3. So up here, exactly. So up here I put 33 and 1/3 percent. Everybody see that? All right. So now let's do this. Now this is going to be for C. We have 1.5, and we want to make this a percentage. So we kind of already know. Let me erase my workstation over here. Pick up my pencil again. And we have, so once again, to go from a decimal to a percent, what do I do? I have to divide, multiply. 1.5 times what? Times 100% over 1. Well, you don't really have to put it over 1. Actually, I don't recommend that. But when I multiply 1.5, is the number getting bigger or smaller? Okay. So which way do I have to go? How many places to the right? Two places, one for each zero, right? 2 zeros. So I have 1.5, and I have to go 2 places. So there's 1, takes me right there. I have 1 more, that takes me right there. I need to add a 0. So when I clean all this up, it looks like 150, 150.0, or 150%. We can get rid of the decimal point, right? So over here for percentages, since we don't want decimal points, we get rid of the decimal point and we add the percentage sign, 150%. Are we okay with that? Okay. And then let's see. We didn't do C. We skipped C, didn't we? This is supposed to be C right here. Okay. So for C now we have. How can we do this? We have 1.5. And when I have 1.5, that is the same thing as saying what? It's like saying 1 5/10, because I have 1, and then I'm in the tenths column, right? So it's 5/10, which is reduced down to 1 1/2. So the fraction is 1 1/2. Everybody see how to do that? Guys, make sure maybe it's really easy for you, but last year I know my girls struggled with this big time. I mean, it was just a big struggle. Now, for the students that were good in math, there's always a handful. They didn't really have any problem with it. But for the majority of the class that didn't really understand this, it really became difficult for them to do. So this is E right here. This is F. Should be G and H. Okay, we're going to look at E right now. We have 60%, and we want to get this to a fraction. Now, can we go from a percent, London? Huh? Go ahead. Huh? 6/10? So you're thinking that this should be 6/10 right here? Or 3/5? Yeah. So would you agree that this fraction is right? 6/10? Huh? Well, let's look at this problem here for a minute. Huh? Yeah, but hey, let's start. Hang on a second. Let's go back here just for a minute and make sure you understand something. That when she put 6 over 10, because we're talking about 60%, it really starts out over 100, right? So this should really be 60 over 100 first. That's what I was waiting for someone to see. Should be 60 over 100, then reduce to 6 over 10 if you want to. Um, I don't know how the test is going to show it, so I would show all three and then maybe circle the small. Well, you don't have to circle; it's obvious. Okay, that should work then. I mean, I don't remember how it was a year ago for me, so I'm not sure how the test is going to ask it. Then we have F, and it wants us to make this into a decimal. So Chelsea, were you the one who wanted to answer this? That was Emma. Huh? 6/10, 0.6. So basically, you're saying it's the same thing as what we had right here. Only we're taking that and we're putting it into a decimal form, right? We're getting rid of the zero, and we're saying that we have 6/10, but we get rid of the decimal. And now that we're dividing, we're making the number smaller, right? This is really 6.0 divided by 10. We're dividing, so the number has to get smaller. We have 1 0, so we go one decimal place, comes over here, and it ends up looking like 0.6. So we put 0.6 there. Everybody see that? Okay. I hope this is not incredibly boring and it's just really, really like boring, but I just know how much they struggled last year with it. And maybe it's because you guys had this accent last year, huh? Okay, so that makes it easy. See, I don't think the kids had this last year. Really? Mm. Well, I'll tell you what, the kids struggled with this last year, so yeah, huh? Public school? Really? Wow. Really? Well, all right, guys. So let's look at G. G, we have the fraction 2 over 1, and we need to make that a decimal. So how do we do that? Yeah, we just divide, right? And so when we divide, what's our answer? Huh? Oh, well, I can use this whole screen here, but when I'm recording, it won't let me go past where this green area is. I don't know why. I'm not sure. So you guys think the answer here is what? 1 and 1/10. Okay. That's not a decimal. Oh, 1.1. 1.1. Okay, you think that's possible? Yeah, it's not. Let's do this. If you have a fraction of 2 over 1, what percent is that? Huh? 200? Absolutely right. 200%. So if that's 200%, can this be 1 and 1/10? Guys, please settle down. What does this have to be as a decimal? If 2, it's 2. Yeah. Yeah, you see that? See how easy it is to make that mistake though? We know that when we have a fraction, 2 over 1, that's a horrible 2. When we have a fraction, 2 over 1, we know that the way we take care of that fraction and make it a percent is we multiply it by 100%. Right? When we do that, we end up with 200% over 1, which is going to, in fact, give us 200%. Okay? And then when we want to take a percent and you want to make it into a fraction, then we know that the percent is always over the number is always over the percent of being 100. So now we have 2 over 100, which obviously we have 2 zeros here, so we get rid of 2 zeros here when we wind up with 2 over 1, which is 2. Remember 2 over 1 is 2, isn't it? Just like 5 over 1 equals 5. Okay, so don't let that confuse you. So even though this is relatively easy and you learned it last year, you can see where it can be a little bit confusing if you're not careful. You understand? Okay, guys. How do you feel about this? Okay? Feel great? All right, I'm glad you feel great. It sounds like you deserve a Tootsie Roll. Okay. All right, so say goodbye and we're going to leave for the day. Yeah.